All right, guys, here we go. This is example number 5 for higher degree equations. Now, when you first looked at this one, you probably thought, wait a minute, Mr. Sawdust is trying to trick us. This has x squared in it. That's the highest power. That would make it quadratic. He's trying to throw in one that we did before spring break, just for good old time's sake. It's quadratic, it's quadratic, it's quadratic. These are the notes we did before spring break. I'll just follow those. And man, I sure hope it leads to the quadratic formula, because that was the most fun one, wasn't it? Woo! All right. Well, okay, I'll bite. It does look quadratic right now. We have x squared. All right, so here's the thing, though. We always have to go with the flow in math as well as in life. All right, stick to math. Don't get philosophical here. But here's the thing. If you start to simplify this, which again, there's no fractions to clear, distribute, yeah. So as you begin distributing here, this is the bit of recognition that would be extremely important. So important that I might get excited here in a minute. So if you're taking a drink of something or eating right now, I would suggest that you maybe put it down, all right? So I'll give you a second, all right? Because look, I don't want you to choke, all right? Got it? Okay, here we go. Because when we distribute that into the parentheses, we hopefully recognize that when we take this times this, we get 2x cubed! Oh my gosh, it's not quadratic anymore. See, I've seen people stick to that script, their initial diagnosis. But once that cubed jumped into the question, that changed everything. And indeed, this transformed into a higher degree equation. So don't stick to the quadratic script just because it was quadratic at the beginning. You gotta go with the flow, all right? So anyway, cubed! It's not quadratic. Oh my gosh. All right, so how do I end this? All right, let's get back to our other one. I hope this is working. All right. And, okay, that threw me a little bit of a loop here. Let me see if I can get this to work okay. Yep, now we're back to this. So here we go. We're done simplifying. Oh, combine like terms. You can't add these. They have different powers. All right. Is the variable in one term? No! Look, there's x's all over the place in this equation. So look, it isn't going to make sense to say what operation is furthest from x. We can't use that inverse operation approach. Sorry, my dear Aunt Sally, we're not going to be able to use you. That kind of sounded funny, but anyway, it's a different approach. So, here we go. When the answer to that is no, and this should sound familiar to you because this is very similar to what we did before spring break when we did quadratic equations, we get it in what the fancy people call standard form, all right? And I want to remind you that standard form is essentially to get everything on one side and make it equal 0, all right? So, the fastest way to accomplish that would be to subtract the 70x over here and get everything on one side. So upon doing that, I'm going to bring this up over here if that's okay. Is that okay with everybody? Okay, good, thanks. So we'd have 2x to the third power plus 4x squared minus 70x equals 0, all right? So remember, we talked about this on assignment 11. The fancy people call it standard form, and here in Burlingame, Kansas, I say, let's go get us a 0, all right? So we went and made that thing equal 0. That's called standard form. So, just like when we did quadratic equations, didn't we investigate whether or not we could factor that expression? And again, factoring would be a flashback. That was something we did on assignment number 5 a very, very long time ago. All right, I'm making a mistake in hitting a button here. I hope that didn't mess things up. Anyway, factoring. So, let's see. Isn't there a common factor? First of all, it's in descending order, third power, second power, first power. Can't we factor out a 2x? This is an old skill. I have to assume you remember it. I sure hope so. But if we factor out a 2x, that leaves x squared plus 2x minus 35 equals 0. All right? We hope that it'll factor even more, and I believe this one will. That's a trinomial. Go back to assignment number 5 and review that if you need to. You know, again, time is of the essence, and I could click the link to factoring, but I just need to keep moving here. So if you look even further at this, I think you'll discover that that configuration will indeed make that trinomial. If you were to distribute this, or if you speak English, FOIL it. The first is x squared, the last is negative 35. The outer, let's just check this, just for the heck of it. The outer is negative 5x, the inner is positive 7x, and you add those, positive 2x, indeed, that is it. So that is how it would factor. All right, so we ended up with three factors here. We have three expressions that have multiplication between them, and it equals 0. So just like on assignment 11, when we enjoyed that prior to spring break together in this very room, didn't we talk about the zero product principle, which basically says if you have a product, that's multiplication, and it equals 0, then for that to occur, one of the factors has to be 0. So this actually ended up with three factors, this expression, and this expression. And if we multiply these three expressions and get 0 for an answer, one of those three expressions has to be 0 for that to happen. That's basically the zero product principle. So we have three equations now, 2x equals 0, which we just divide the 2 and that leads to 0. Then we have the equation x plus 7 equals 0, which is easy to solve. We just subtract over the 7, and that leads to the value of negative 7. Excuse me. And then we have x minus 5 equals 0, which, there again, we add the 5 over, and it leads to x equals 5. So we got three solutions here, three real solutions, and there they are. If you would please try to remember, it makes these much easier for me when I'm looking at them, to put them in a solution set and circle it. I would greatly appreciate that. So those three values of x solve that equation, and that's what it means to be a solution. Now, let's just address this while we're at it. If you're of the mind that you don't want to factor it, no. Are there formulas, much like the quadratic formula? I'll say to you there are formulas, all right, but they're not like the quadratic formula at all. Here, for example, is a different way we could have done this very same question without factoring. To get those three answers, and you don't need to listen anymore if you don't want to, because I don't advocate using the formula approach here, as you're about to see. Factoring was the way to solve this. But there would be three formulas similar to the quadratic formula that would have discovered those three answers, and they're called the cubic formulas, and here they are on the screen. And I think I also gave them to you in your printout here. So, you know, have at it if you'd rather find these three answers by plugging these coefficients, 2, 4, negative 70, into these three formulas and crunching them out. Be my guest. I don't suggest that though. So, again, instead of using the cubic formulas, let's just consider that to be beyond the scope of this class. Let's use factoring. And guess what? Mr. Soybean is going to make sure that these things factor to some extent. It would be unreasonable for me to give you one that did not factor and force you to use those cubic formulas to find those solutions. All right, fair enough? I'll leave that up here for another 10 seconds or so, and you better start memorizing it because it's going to be on the final. Ha ha.